Okay, so we come back to that recording and we divided our 20 by 9,8 and we got 2,04 and our acceleration is 0,98 meters per second squared. Okay, now we're going to make this a little brighter and let's move to the next example, which is example number 6. And in example number 6, now I can use this side of the book. In example number 6, you can see that you have a man who's pulling on this crate. Okay, so the crate is 130 kilograms. Okay, and he's pulling that with a force of 500 newtons at an angle of 30 degrees to the horizontal. Remember, your horizontal is here. Okay, and the coefficient of static friction between the floor and the crate is 0,4, and the question is, will the crate start to move? So what I'm going to do is I'm going to redraw this diagram. Let's keep this a bit straight here. Redraw the diagram. So here I have my crate. My crate has a mass of 130 kilograms. This crate obviously has a force that's pulling it, a force of 500 newtons, and that force is acting at 30 degrees to the horizontal. Okay, now remember, this force will have two components. It's going to have the horizontal component and it's going to have the vertical component. Okay, so you should know components very well now, remembering that FV, which is the vertical component, some of you call it FY. It doesn't matter what you call it, the formula is the same. It's F sine theta. And your horizontal component you can call FH, or you can call it F of X, and that formula is F cos theta. Okay, the other thing I forgot to add on here, I'm assuming that this object is going to move to the right, and therefore I'm going to have a frictional force because they gave me the coefficient of friction, so I do know that there is going to be a frictional force acting on to that direction. Okay, and then the question asks, will the crate start to move? Okay, so when will this crate move? The crate will move if the crate will move if, do you agree that if the horizontal component, which is FH, is greater than your frictional force? That's the only time it's going to move. If they equal, it will stay in one position. Okay, if the horizontal component is less than the friction, nothing's going to happen. It's going to stay in one place. Only when your horizontal component is larger than your frictional force will this move. Okay, so let's take it from working out what our horizontal component is and what our frictional force is going to be. Okay, so for our horizontal component, we can calculate that to be F cos theta, which would be 500 cos 30 degrees, and that would give me 500 cos 30 degrees gives me 433 newtons to the right. Okay, Can I work out my frictional force? I can, because they gave me the coefficient. It's mu s times the normal force. Now remember, when an object is pulled, this object is being pulled, okay, like this, at this angle 30 degrees. Now remember, when the object is being pushed or pulled, the normal force is not equal to the weight. So we can't say that because this is 130 kilograms, we multiply that by 9,8 and we will get our normal force. If we look carefully in this diagram, we have our weight which acts downwards. Yes, that's going to be 130 multiplied by 9,8. But we also have our vertical component of our 500 Newton force. That vertical component is F sine theta. Okay? And if I work out what my vertical force F sine theta is, I get 500 sine 30, and I get my vertical component to equal to 250 newtons. Okay, so now can you see that you have two vector quantities that act in the opposite direction? So my normal force now will equal the resultant of these two. So my normal force is weight minus my vertical component. Okay, and the weight is 130 multiplied by 9,8 minus 250. Please note, this is a common error. Students immediately go and say normal force, and they would say 130 times 9,8. Okay, so don't make that mistake. Okay, and that gives me 1024 newtons. So that's my normal force. So now I'm going to substitute that in this equation. 0,4 multiplied by 1024, and I then get my frictional force to equal 410 newtons to the left. So will the box move? The horizontal is equal to 433. The friction is equal to 410. Will it move? No, it's not going to move. Why? The pulling component